All right, welcome back. Today we're going to review for our Chapter 5 test. You've been given a review packet. You may be curious about exactly what we're going to do here. We're going to go through the review packet. We'll work on problems from that packet that you've been given, so you can follow along as I discuss those problems in the video and use those to help you answer other questions that you might be working on in the packet. Of course, we'll all be in here in class together, and if you're having questions, speak up and we can make sure you get all your questions answered today, hopefully, before you leave, so that you're good and ready to go for the test tomorrow. Make sure that you follow along with us in the packet and understand what's going on. If you don't, again, make sure that you're asking questions. Okay, that said, let's jump in and look at our first example. A large retail company encourages its employees to get customers to apply for the store credit card. Below is a distribution for the number of credit card applications received per employee during an 8-hour shift. Okay, so the employees are asking customers if they want to purchase a credit card, and they have a breakdown on the different outcomes per shift of the number of customers that sign up for the credit card. Probability of 0 is 27%. The probability of 1 person signing up would be at 28%. Probability of 2 people signing up would be 0.20. And the probability of 3 people signing up would be 15%. 4 people signing up would be 8%. And of course, 5 people signing up would be a 2% chance. The first question is, what is the probability that the employee will get 2 or 3 people to sign up during their shift? Now remember, or when we're talking about probabilities means to add. So we're talking about the probability of 2 plus the probability of 3. So we'll simply look at 2 and 3 and their probabilities. The probability of 2 would be 0.20 and the probability of 3 was 0.15. So we just add those two together and we see that the probability of 2 or 3 is equal to 0.35 or 35%. Meaning there's 35% that either 2 or 3 people are going to sign up for the credit card during an 8-hour shift. Part B asks us to find the mean for the distribution. Now we've been working with binomial distributions, so the mean is a little bit different for those than it is for this type of distribution. This is a discrete probability distribution. So to find the mean of the distribution, hopefully you recall that you're going to take every item X and multiply it by its probability. And then we'll just add those together. So to find the mean, that would be 0 times 0.27 plus 1 times 0.28 plus 2 times 0.20 plus 3 times 0.15 plus 4 times 0.08 and then plus 5 times 0.02. So we would take all of these numbers and multiply them out first, of course, and then add them up individually. So we multiply 0 times 0.27, that's 0. 1 times 0.28 is 0.28. 2 times 0.20 would be 0.40. 3 times 0.15 would be 0.45. 4 times 0.08 would be 0.32. And then 5 times 0.02 would be 0.10. Okay? So our mean would be equal to the value that we get when we add all these up. 0 plus 0.28 plus 0.40 plus 0.45 plus 0.32 plus 0.10 is equal to 1.55. That is our expected value for this distribution, the mean. Okay? So we go on down to the next question, which is a much more involved question. We're asked to find the variance of the distribution. Now, remember what we're going to do to find the variance is we are going to take every number x, we're going to subtract it from the mean, square it and then multiply it times its probability. We'll just add all those up. So that's where we get our variance. So we'll go ahead and begin doing that. Our first number is 0. If you go back up to the table, we're talking about 0 here. So we're going to say 0 minus 1.55. This is a symbol for variance. 0 minus 1.55 squared. And we'll multiply that times 0.27. Then we'll take the next number, which is 1 minus 1.55 squared times 0.28. Now again, all of this is coming from the table. I took 1 minus 1.55 and multiplied it times 0.28 after I squared it. We'll continue on the same path. Let me move some of this stuff out of the way. 2 minus 1.55 squared times 0.2, I believe it is. Then we're going to take 3 minus 1.55 squared. We'll multiply that times 0.15. And I'm running out of space, so I'm just going to come down underneath. 4 minus 1.55. Do this. 4 minus 1.55 squared times 0.08. And then lastly, 5 minus 1.55 squared times 0.02. Okay, so at that point, we just got some calculations to be made. We probably use our calculator to help us out a lot. 0 minus 1.55 squared times 0.27. That all works out to be 0.6487. 1 minus 1.55 squared times 0.28 is going to be 0.0847, I believe. Okay, then we can take the next number. I'm working out 2 minus 1.55 squared times 0.2, and that gives you 0.0405. We'll continue on down here. 3 minus 1.55 squared times 0.15, that works out to be 0.3154. The next step comes down here. 4 minus 1.55 squared times 0.08, and that works out to be 0.4802. And again, I apologize for running off onto the next line, but hopefully you can follow with what I'm doing. 5 minus 1.55 squared times 0.02 works out to be 0.2381. So our variance will be what we get when we add all of these values up together. And that works out to be 1.8, basically, somewhere around there. So we'll have a variance of 1.8 for this problem. Now, 1.81, I believe, if you do 2 decimal places. So to find the square root, or I just gave the answer away. If I was going to find the standard deviation, which it didn't ask for, but if it did ask for the standard deviation, I would just take the square root of this value, and that would be my standard deviation for the problem. Okay, so a good indication of how we find the mean, just real quickly recapping. To find the mean, we multiply every number times its probability, and then we add all of those values up as we go. To find the standard deviation, or the variance in this case, I take each number and subtract it from the mean that we got and multiply by the probability after I square it, of course. And then we add all those values up, and that gives us our variance. Okay, moving along. Our next problem involves dealing with a card game. We've got a card game that involves removing all of the hearts from the deck and placing those 13 cards in a bag. The player will draw one of those cards with the following rules. If the ace is drawn, the player loses $20. If a face card is drawn, the player wins $10. If any other card 2 through 10 is drawn, the player wins $2. And then it asks us for the expected winning on each play of the game. And hopefully, by this point, you've become familiar enough with this word to understand what that's asking us. That is asking us to find the mean. Anytime we hear about expected values, expected outcomes, we are talking about the mean of our distribution. So let's take a good look at this. First off, let's realize that we are only dealing with all of the hearts from the deck. We're going to take all those hearts out of the deck and we're going to put them in a bag. Okay, so I have the hearts listed over here on the right now. That was magic, I made that up here, huh? So we're now going to take a moment here and come up with a probability distribution. The first thing we need to do is look at the outcomes. Okay, our outcomes in this problem, obviously we can have different cards, but the outcomes that we're going to have are based on the money. We want to look at the expected winning, so we're going to find the winning outcomes. Unfortunately, the first thing is losing $20. So that's one of the outcomes that we can run into. The second one is winning $10, so that would be a positive $10. And our third outcome is winning $2, so that would be a positive $2. And at this point, once we've identified those outcomes, we're going to identify the probabilities of each of those outcomes. Now, the first one, to lose $20, we have to draw an ace. Well, you have 13 cards over here, and the ace is the only one of those cards that would make this happen. So out of the 13 cards that are there, one of them gives us a chance to lose $20. The next outcome, winning $10, is going to occur on a face card. Well, the face cards are Jack, Queen, and King. Now, we're just talking about drawing one card out of the deck, of course, but these are our face cards, and they would all give us $10. So we have 3 chances to win $10 out of the 13 possible cards that can be drawn. So 3/13 would be the probability of winning $10. The rest of the cards, 2 through 10, are going to make us win $2. And basically all we have to do is make sure that we have something that's going to account for all 13 cards. That really only leaves us with 1, 2, 3, 4, 5, 6, 7, 8, 9 cards out of 13. And again, double check. Make sure all of your probabilities add up to 1. Okay, or 100%. You can't have any negatives. All the probabilities have to be positive. They have to be between 0 and 1, and they all have to add up to be 1. So now that we've identified our distribution of values, we're going to now figure out the mean of these by multiplying each value times the probability of its occurring. So this is going to give us negative 20 times 1/13 would be negative 20/13. And we'll get to the decimal part of this in a minute, but right now we're just going to leave it as a fraction. 10 times 3/13 would be 30/13. And then 2 times 9/13 would be 18/13. So we have negative 20/13 plus 30/13 plus 18/13. This is going to give us negative 20 plus 30 is 10 plus 18 is 28/13. Well, we don't want our answer to come out in a fraction because we're talking about the amount of money that we're winning. So we're going to rewrite that as a decimal in terms of money. So this means that our mean is 28 divided by 13, and that's going to give us what would round off to be $2.15. Now what that is saying is, if I played this game many times, it would average out that I won $2.15 every time that I played it. Okay, so let's take a look at this last example. 3 out of 5 American adults under the age of 35 have eaten pizza for breakfast. A random sample of 20 adults under age 35 is selected. What is the probability that exactly 14 of them have eaten pizza for breakfast? Well, hopefully we can pick up on this. This is what we call a binomial probability. Okay, so when we read that, we should know certain things are going to happen. We need to identify real quickly our N, P, Q, and X, and all that stuff that we've got to have to work this problem out. As we read this problem, the age 35 has nothing to do with anything as far as the numbers go. This tells us, when we read that there's a sample of 20 adults, that tells us our N is 20. When we read 3 out of 5 American adults, that should tell us that our P is 3/5 or 0.6, which also tells us that our Q is 0.4. Now when we read part A, it asks us what is the probability that exactly 14 of them have eaten pizza for breakfast. So that's telling us that X is 14 for this part of the problem. So a couple of things. First off, we could do this by hand and say the probability of 14 is equal to n factorial, which would be 20 factorial, over 20 minus 14, which is 6 factorial, and then 14 factorial, all times 0.6 to the 14th and 0.4 to the 6th. Now we could work all that out. However, another issue that we could, or another thing we could pick up on here is that with P equaling 60% or 0.6, we can use the table in the back of the book for this problem as well by just locating the part where N is 20 and P is 0.6. But for this particular problem, we can easily multiply this out just as fast. So that works out to be 0.124. So the probability that we have exactly 14 adults that eat pizza for breakfast is 0.124. Now part B asks what is the probability that less than 12 of the 20 adults have eaten pizza for breakfast. Well, less than 12 actually means every number starting at the number less than 12, which would be 11, and all down to 0. So what we have to do is find the probability of 11, find the probability of 10, probability of 9, probability of 8, probability of 7. We're going to have to find the probability of 6, probability of 5, probability of 4, probability of 3, probability of 2, probability of 1, and the probability of 0. We're going to have to find all of these things and add them up. Luckily for us, these are in the table, so we could quickly do that. And you'll find that some of them we don't even have to really worry about. Probability of 11, if we look in the table where n is equal to 20 and p is 0.6, where we make x equal to 11, the probability is 0.160. The probability of 10 is 0.117. The probability of 9 is 0.071. Probability of 8 is 0.035. The probability of 7 is 0.15, or excuse me, 0.015. The probability of 6 is 0.005. The probability of 5 is 0.001. And beyond that point, 4 is 000, and so are the rest of these. These are all zeros. So we really only have to add up from 5 through 11. And what we're going to do is add up all of these probabilities together and find out that the probability that x is less than 12 is actually equal to 0.404. And that is the answer to part B. Now moving on to part C, we're asked what is the expected number of adults in the sample that have eaten pizza for breakfast? Well, again, expected number automatically should make you think of one thing, and that is mean. Okay? Mean, just another way of saying expected value. The mean of a binomial distribution is always equal to n times p. And if we go back up real quickly, n was 20 and p was 0.6. So we're going to take, to find our mean, we're going to take those values and multiply them together. So our mean is going to be equal to 20, which is n, times p, which is 0.6. And 20 times 0.6 is 12. So we would expect, out of our sample of 20, we would expect 12 adults to have eaten pizza for breakfast. That's our mean. Sorry. Okay, so our mean is 12 adults. Now, part D asks, what is the standard deviation of the adults who have eaten pizza for breakfast? Well, you'll remember that formula as well, hopefully. The formula for standard deviation of a binomial distribution is the square root of n times p times q. So when we take those values and work out our value for standard deviation, that's going to be the square root of 20, which is n, times 0.6, which is p, times q, which is 0.4. So we have 20 times 0.6 times 0.4, and that gives us 4.8. So the square root of 4.8 is our standard deviation, and that is equal to roughly 2.19. So our standard deviation for this distribution is 2.19. Now again, recapping real quickly, we identified this as a binomial probability because everybody either ate pizza or they didn't eat pizza. So everything was a success or a failure. So we knew this was binomial probability. We had a set number of trials that we were going to deal with. So we went ahead and used the binomial probability formula. We worked that out for 14 because it was exactly 14. And we got the value of 1.124 being the probability that exactly 14 out of the 20 people ate pizza. Then we were asked to find out what's the probability that it's less than 12. Well, less than 12 is all of these different values, so we had to find their probabilities. To save some time, we used the table for that, and then we added all those values up to find that probability that x is less than 12 is 0.404. To find the mean, which we had to do in part C, we multiplied n times p, and that gave us 12 adults. And then to find the standard deviation, we took the square root of n times p times q, and that gave us 2.19. Okay, that's about all I have for you today. Hopefully, if you're having some questions still with these, you'll get a chance to speak to me in class. Make sure you practice the rest of the problems in the packet. It would definitely help you prepare for the test. As you know by now, the reviews can be very, very helpful in preparing for the test. So go ahead and finish those problems in the packet, and I hope to see you tomorrow where you'll do good on the test.